Okay, welcome to day 2 of our cubic functions unit. We're going to be looking at transformations today, but specifically focusing on A and B and what effects those have on our function. But to begin with, we're going to take a quick review of functions and what happens as we change different variables. Okay, so if we allow f of x to equal this little function over here with points at -3, -3, +2, and then down to 4, -2. We're going to see what happens when we change different parts of our transformation equation. So in this first one, if we had f of x, and we're going to change that h to a c, okay? So let's change that to a c because that's what we have in our equation. What happens when we have an equation that says x plus c? We know that the horizontal translations make it move the opposite of what it looks like here. So if we let c equal, let's say c equals 2. The way we find our values is, for every x point on our function, we are going to add the negative of c. So if it looks like this is a positive c, we take the negative. So if we're saying c is 2, we're adding that. Our y values do not change. And what c causes it to do is a horizontal translation. Sorry, I can't fit all of the word in there, translation. Okay, we know that this will move right if c is greater than 0, and we move left if c is less than 0. So when c is 2, we're going to be moving 2 to the right. And our equation should really have a negative in here. If it said x minus c, we're moving to the right. So this point at -3, -3, we're going to move to the right by 2. So our coordinates now will be at -1, -3. So again, the y value doesn't change, it's only the x. The point that was at 2, 2 moves over 2. It is now at 4, 2. And the point that had been at 4, -2 moves over 2 points, or 2 units to the right. So it is now at 6, -2. And again, the key here is our x values, we add the 2. The y value stayed exactly the same. Okay, as we continue on, let's look at what happens if we add k. And again, for transformations with cubes and everything, we actually are calling this d this year, so change that to a d. So if we add d, our x values don't change. So no change to the x values. And our y values, we add d to each one. So the result is we get a vertical translation. So vertical translation. We move up if d is greater than 0, and we move down if d is less than 0. So let's pick a value for d in this example. How about we say d equals, a +1. So because d is positive, we know we're going to move up. And again, we're looking at our original function. So it was at -3, -3, and we're going to move up by 1. So the x value stays the same. The y value, we add 1. So -3 plus 1 gives us -2. Our point that was at 2, 2 moves up to 2, 3. And our point that was at 4, 2 moves to 4, 1. negative 1, excuse me, for negative 1. And we would connect these points. So it still has the exact same shape, it has just been shifted upward slightly. Okay, let's take a look at j of x. We obtain j of x by multiplying our function f of x by a negative. Let's take a look at what happens when we multiply by negative 1. Our x values have no change, and our y values have been multiplied by negative 1. This resulted in a reflection across the x-axis. So whatever had been below the x-axis will be above it. Whatever started above it will be below it. And let's take a look at what happened to our original points. We had a point at negative 3, so our x value is going to stay the same. The y value we multiply by negative 1, getting negative 3, positive 3. So negative 3, positive 3. Our second point had been at 2, 2. X stays the same, y is negative. So that is now at 2, negative 2. And our final point had been at 4, negative 2. It's now going to be at 4, positive 2. And if we connect these, we have the same shape but has been reflected. It's been flipped over. Okay, so that's what that does. Those should all be very familiar to us. We've been using these transformations. But here's where things change a little bit. We're going to take a look at when we multiply our function f by a value of a. So we know from the past that a controls our vertical. We either can get a stretch or we can have a compression. And we get a stretch if a is greater than 1, and we get a compression if a is less than 1. And the way we see that happen is our x values stay the same, so there's no change. So our x values with a vertical stretch or compression stay the same. Our y values are multiplied by a. So let's pick a value for a. How about a positive 2? And let's see what happens to all those original points. We think it should stretch, have a vertical stretch since a is bigger than 2, or bigger than 1. So we start at negative 3, negative 3. X value is going to stay the same. My y value is multiplied by this. So the value was negative 3 times 2 gives me a negative 6. So the coordinates of this point now are negative 3, negative 6. Likewise, every point gets multiplied by, every point's y value gets multiplied by 2. So at 2, 2, it now becomes 2 times 2 is 4. So the new point, or the point on k of x, is at 2, 4. The point that had been at 4, negative 2 is now at 4, negative 4. So connect these guys, and you can see that we've pulled these pieces away from the x-axis by a factor of a. So it's stretched the points up and stretched the points downwards. And again, our x values stay the same, only the y's changed. Okay, here's the new piece, b. So our function m of x, our b is multiplied by x when we look at the function. And the b, when we multiply by x, then the function operates on it. What's going to be different here, our y values are going to stay the same, so no change here. and we're going to have horizontal either stretch or compression. So what happens here is every x value is going to be multiplied by 1 over b. So we're going to get a stretch if b is less than 1, and we'll get a compression if b is greater than 1. These are the opposites of what happens with our vertical stretch and compression. Okay, so what happened to our points? Let's let b equal, how about 2? Okay, so our b value is 2. That means we're going to get a compression because b is greater than 1, and the value of the compression is going to be 1 over b, which is 1/2. So we're going to multiply the x values by 1/2. So we started out with x at -3, -3. So -3 times 1/2 is -1 and 1/2. It's right there. The y value stays the same. So that's -1 and 1/2, comma, -3. I know that's difficult to read there. Okay, our second point was at 2, 2. The x value we're going to multiply by 1/2. So 2 times 1/2 is 1. The y value stays the same. So it's at 1, comma, 2. Our third point had been at 4, -2. 4 times 1/2 is 2, and it's still at -2. So that's at 4, that's at 2, -2. And I'm just going to connect our points in the same order our original function was. I'm going to draw in the original function on here also, just so we can see a little interesting thing happening. This had been here. What's happened is we've multiplied by 1/2, so we've compressed our function in towards that y-axis. We've come along from the sides and squished it together. So we've compressed it. So even though b is a whole number, we've compressed it together. So we've made this smaller. If b had been a fraction, we would have stretched it outwards from the y-axis. Okay, so I know this is a little different, but we just have to remember that b operates the opposite of a, and in the horizontal direction. Okay, let's take a look at the next page. So we're going to come back now to our cubic function and see what happens here. And this is just from our notes last time. If our x values were between -2 and 2, this is what our y values would give us. So here we're going to look at our x values, and we're adding an a of 2. So if you look back on our previous page, we said a just multiplies your y value. So if x was -2, y should be -8, but we have to multiply by 2, so we'll get a -16. If x is -1, x cubed is -1 times 2, so -2. When x is 0, we plug that in. 0 cubed is still 0 times 2 is still 0. And then we do the positive. So 1 cubed is 1 times 2. 2 cubed is 8 multiplied by 2, so that's our a value, and we get a +16. So if we just look at this little piece of our function, the domain on this piece we're looking at goes from -2 is less than or equal to x is less than or equal to +2. My range went from -8 is less than or equal to y is less than or equal to 8. And again, that's because we're looking at just a little piece of our function, not the whole thing, because we want to see what happens to this as we modify a. My domain stays the same. So negative 2 is less than or equal to x is less than or equal to positive 2. But my range has changed. It has expanded to positive 16. Okay, let's let a equal 3 and see what happens here. So if x equals negative 2, negative 2 cubed is negative 8 times 3 is negative 24. Negative 1 cubed is negative 1 times 3, negative 3, 0. And then we have our positive side. So again, my domain has changed, stayed the same, but my range has expanded by a factor of 2. Okay, so A caused us to change our y values, which caused our range to change. Our domain stayed the same. When we look down now at B and changes with B, we're going to look at just a piece of our parent function. So we're looking again from the domain being from negative 2 to positive 2. So negative 2 is less than or equal to x is less than or equal to positive 2. And we got a range from negative 8 to positive 8. Okay, so let's say we're going to let b equal 4. So that means we're multiplying our x value by 4 and then putting it into our function. So 4 times x, all of that cubed. And that's how we know it's a b value, not an a. A values don't get cubed, b values do. So we want to keep from the previous page, we know that our range, our y values do not change when we have a b value. So we're going to put in these same y values, our same range. Okay, so we've got negative 8, negative 1, 0, 1, and 8. We're keeping the range exactly the same. Okay, so from my parent function, what value gives me a negative 8 for y? We know that a negative 2, when it's cubed, gives us negative 8. But right here, this is 4 times that value. So 4 times x has to equal negative 2 to get this negative 8. So I need to figure out what x value has to be here, that I would have to multiply it by 4 to get my value of negative 8. So to find out what x value I had to put in here, I have to come over here. Let's see if we've got a little room here so you can see this. So 4x has to equal negative 2. So if I want to know what x is, I divide by 4. So x must equal negative 1/2. So the x value is negative 1/2. Negative 1/2 times 4 gives me a negative 2, which when I cube that, I get negative 8. So my x and y points here would be negative 1/2, negative 8. Likewise, if I want a y value of negative 1, I knew I had to plug in a negative 1. But I want to know what b, when b is 4, what would the x value have to be? So 4x equals negative 1. Divide both sides by 4, and I get negative 1/4. And then we do the same with 0, which of course is 0. And with the positives, we have the same thing happening. Positive 1 would give me a positive 1 for y, but that's really equal to 4 times some value. So, and that value is 1/4. With 8, we know if we use an x value of 2, or an input value of 2, we can get 8. But that input value is really 4 times our x. So 4x equals 2, so x equals 1/2. So my points here, my range has stayed the same. So it's negative 8, less than or equal to y, is less than or equal to positive 8. But my domain, take a look at our domain. Our domain has gone from negative 1/2, not y, domain is x's. So our domain is from -1/2 is less than or equal to x is less than or equal to +1/2. What has happened to my domain? It's been compressed inwards, right? So it's been horizontally compressed by, what would I have to multiply -2 by to get to -1/2? It's been compressed by 1/4, which is 1/b. So not only are my x values compressed, the domain is actually getting compressed too. This doesn't really matter when we're looking at the whole parent function because the domain is all real numbers. So compressing it still leaves all real numbers. Okay, let's take a look when we let our b value be a fraction. So if we say b is 1/2 x, I'm just putting the 1/2 so we can remember what that is. We want our y values to stay the same, our domain, our range. So it's -8, -1, 0, 1, and 8. We know that to get a y value of -8, our input has to be -2. But that input of -2 is 1/2 times some value of x, because we're letting b equal 1/2. So 1/2 of x equals -2. To find what x is, I have to divide by 1/2. Again, when you divide by a fraction, you take the reciprocal and multiply it. So -2 times 2/1. So x must equal a -4. So the x value is -4. When we multiply that by b, we get an input value of -2. Cubed gives us the -8. Okay, -1, the input value has to be -1. To find the actual x value, we had to take the 0.5 and divide by that, which gives us a -2. 0, 0. We know our positives operate in the same way. +2, +4. So now we know that if our x value is -4, when b is 1/2, y will be -8. So our domain has changed. It is now goes from -4 is less than or equal to x is less than or equal to +4. So relative to the little piece we were working with, it has been expanded or stretched horizontally. Our range has stayed the same. So it still goes from -8 is less than or equal to y is less than or equal to +8. Okay, so if we were to describe this transformation when b was 1/2, it has been horizontally stretched by a factor of 1/1/2, which is equal to 2. So it's been horizontally stretched by 2. It's been pulled away from your y-axis by a factor of 2. I know, stick with us, it actually gets a little bit easier. So in summary, what changes in A change the y value. So we get a vertical stretch or compression. If we change B, it causes changes in the x value. So we get a horizontal stretch or compression. And that stretch or compression is by a factor of 1/b, whereas our vertical stretch or compression is by a factor of a. So again, remember, B's are going to operate the opposite. Okay, let's take a look at the third page. Almost there, guys. So here's where we're just going to take a look at an equation and describe what's happened to it. So we're looking at our parent function of the cube. So we've got our cube right there. And notice the difference between A and B. A does not get cubed, where b does get cubed. So that's one of the ways to tell them apart. Also know that we cannot figure out what our c value is unless we have just a single x here. So that's going to become important. Okay, so on this first equation, 2, that's an a value. 5 gets cubed, so that's b. So this has, if a is 2, that means there's a vertical stretch by 2. B, since b is 5, that's going to be a horizontal. And is that a stretch or compression? So remember, if b is greater than 0, or greater than 1, it's going to be a compression. So horizontal compression by 1 over 5. So it's compressed inwards by 1/5 and stretched upwards or downwards by 2. Okay, on this next one, this 3, that must be a b value since it does get cubed. This is c and this is d. So we have no vertical stretch or compression, but we do have a horizontal compression by, again, 1 over b, so that's 1/3. We've shifted right by 2, and we've gone up by 2. All right, next one. Again, this 0.5 is to the 3rd power, so that must be a b value, c and d. So we've got a horizontal. If it's a fraction, so less than 1, it means it's going to be a stretch. So a horizontal stretch by 1 over 1/2, which is equal to 2. We also move to the right by 1, and we move down by 3. Almost there, guys. Okay, let's take a look at this 4th one. Okay, this looks like we don't have an A, we have B, and we have C. But remember what I said, we can't figure out C until we factored out our B value. We have X by itself. So what can we factor out in here? We're going to have a 2 times X minus 2, all of that cubed, plus 1. So now we can see that this 2 represents B. So that's a horizontal compression by 1/2. And now we see we truly only moved 2 to the right, not 4. So we moved right by 2 and up by 1. So notice that B is not affecting that D value at all. Okay, we've got an A, we've got a B, we've got a C, and a D. Very exciting stuff. So A value of 2 tells us the vertical stretch by 2. We've got a horizontal, if B is 3, it's a compression, horizontal compression by 1 over B, so 1/3. C value is positive 5, so we move to the right by 5, and we move down by 2. A lot of work there. Okay, one last thing. Let's take a quick look at some graphs, and no, you will not have to do this on the homework or on the knowledge check, but let's just see if we can identify these graphs. Okay, this first one is the parent function. So this one is y equals x cubed. Okay, now these other two, we've got a dashed one and a solid. Both of these have obviously been shifted over 1, so that tells us our C value is 1. And I did that primarily so we could see if they've got a stretch or a compression on them. Let's take a look at the solid line first. If we were looking at our parent function, if we stepped 1 over from our inflection point, we would have to go up 1. In this case of the solid one, if we step over 1, I'm going up 2. So my x value is staying the same, my y value has changed by a factor of 2. And which value, A or B, can change your y value. Do you remember that? It's my A that changes the y. So this one is y equals 2x cubed. And notice the 2 is not getting cubed. So let's take a look at our dashed line. If we are compressing this horizontally, our y's stay the same. So here we go. If my y value is 1, how much has x been multiplied by? So instead of stepping over 1, I only went 1/2. So my x has been multiplied by 1/2, which tells me my b value is the inverse of that. So 1 over 1/2 is actually 2. So my b value is 2. These are what they look like. Although both y equals parentheses 2x cubed and y equals 2 then x cubed, both are narrower than the parent function. They've become narrower in different ways. So when you have a b value, it's pushed it together, whereas when you have the a value, it's pulled it upwards. Okay? So now, if you want to review this yourselves, you're welcome to. It's on the website. But good luck on your homework, and come see either myself or Mr. Alexander if you have questions. Thank you.